Have you ever asked yourself what kind of motor is used in this French intercity train? Well, this train has a three-phase synchronous motor. As the name indicates, this three-phase motor runs at constant speed independent of the load. You can get this high-efficient motor in different sizes, and its appliances are varied. The basis of this motor forms the rotating magnetic field, which is produced within the stator by this power supply. The so-called RMF was already explained in another video, so let us have a closer look at the rotor. The rotor consists of constant magnetic poles, which can exist of permanent magnets or be excited by a DC power supply like shown. Assume the rotor has initial rotation in the same direction as the RMF. The A-positive poles of the RMF and the rotor attract each other and get locked magnetically. But if you start this motor at standstill directly, the inertia of the rotor avoids that the rotor can get locked to the RMF. So how make a synchronous motor self-starting? To make this motor able to self-start, a squirrel cage is fitted within the pole tips. So the RMF induces voltage within the squirrel bars and the motor starts just like an induction motor. At maximum speed, the rotor field coils are energized. Now the poles of the rotor can interlock with the poles of the RMF. At synchronous speed, the relative motion between squirrel cage and RMF is zero, and therefore you have no induction voltage within the bars of the squirrel cage. That's why it will not affect synchronous operation of the motor. A synchronous motor runs at constant synchronous speed, regardless of the load. As load is applied to the motor, the so-called torque angle increases. Note that there is no change in speed. But if the counter torque is increased beyond the maximum torque of the motor will slip out and stop. Let's discuss some information given by the nameplate. All this data refers to the nominal range. The motor's rated mechanical output power is given in kilowatts. The motor rated speed, or full load RPM, refers to full load. This electrical data is important for the stator windings. Here, you can connect the motor in delta. Note that the power factor at rated operation is 1. If the magnetic field of the rotor is excited by a DC power supply, you have further information to connect the rotor. Talking about its appliance, synchronous motors are, for example, used in high-performance industrial drives for compressors, blowers, and pumps, where an absolutely constant speed is required. Also, in some instances, you find this motor in drive systems for trains. The French train à grande vitesse, or TGV, are some well-known examples. If the motor is overexcited, the motor starts operating as a leading power factor. This way, you can improve the overall power factor. By the way, the graph drawn between armature current and field current is known as V-curve. Note that this synchronous motor and a three-phase generator are of the same structure.